Welcome to Inspired Mechanical. In this video, we are going to cover basic concepts of projection of straight line. So what the straight line is? A straight line is the shortest distance between two points. Here we are going to discuss various 9 points about projection of straight line. They are described as, first case will be parallel to one of the reference plane or both of the reference plane, and second case will be contained by one or both of the planes. We will discuss one by one all these. These are the following 9 cases. Third is perpendicular to one of the plane. Fourth one is inclined to one plane and parallel to other plane. And fifth one will be inclined to both the planes. And sixth one will be projection of line inclined to both the planes. Up to point number 4 we will cover in this video, and in the second video we will cover all these 5 topics. So sixth will be projection of lines inclined to both the planes, and seventh will be projection of a straight line and its inclination with the reference plane, and eighth one will be method of determining traces of line, and ninth one will be position of traces of a line. So these 4 topics are very important from the exam point of view, and these are the basic concepts. So we will cover one by one, starting from point number 1. So here is our point number 1. See, line will be in 3 cases. First one will be line parallel to one or both the reference plane. These are the various cases. This all comes under this case. First one will be, this one is vertical plane and this one is horizontal plane. Line is shown by this blue color line, capital A and B. Line is parallel to one or both the reference plane. This particular line is parallel to one reference plane, and that one is HP. Line is inclined to HP but parallel to VP. But this case is line parallel to one or both the reference plane, so this line comes under this category also. So where will be its top view? When we see the top view from the above, the point A will be projected over here. With this green line we show top view, and this is the top view with small line, small a and small b. Capital B will be projected just below it. Okay, and when we see from the top view from here, point A will be projected on vertical plane and point B will be projected on vertical plane also. And this is our front view, which is shown by red color line. Okay, and when we rotate the horizontal plane 90 degree clockwise, we will obtain just this projection. This is the front view, which is shorter than the length of line. We can see the true shape, or you can say true length of line, in the top view. So we will start with top view and draw a horizontal line XY and take this position, which is in front of VP. This one is also in front of VP. When we rotate the HP 90 degree clockwise, this projection top view will be just below the reference line XY, and this will be the true shape of line. Suppose this line is 70 mm, it will be 70 mm in top view, but in front view it will be shorter. So this line, red color, A dash, B dash, point A dash and point B dash will be projected just above the small a and small b, but the length is shortened. So this is our small a, this is small b, this is top view, and here will be some angle, okay, which is shown by angle phi, right? We will discuss it later in terms of angle. Let's move to second case. In this second case, the line is inclined to horizontal plane but parallel to horizontal plane, parallel to vertical plane, sorry. So this blue color line is our given line, capital CD line, and its front view will be projected on vertical plane, which is shown by small c dash and small d dash, and its top view will be shorter, which is shown by green line, small cd. This will be shorter. So in the view in which the line is projecting completely, or we can see the true shape of the line, we will start with that. So we will start with front view because line is in its true form. So draw an horizontal line XY and mark these points C dash, or you can say D dash if angle is not given, and in case angle is given, mark point C dash and make an angle of 30, 40, whatever given in your exam, and mark C dash D dash, which is the actual length of line, or you can say true length of line. Okay, and the top view is just below capital C there will be small c, and just below the capital D there will be small d. Similarly, after rotating HP 90 degree clockwise, we will get small c and small d, which is just below the C dash and D dash, in such kind of a manner. So last case is this one, line parallel to one or both the reference plane. This is the case when the line is parallel to both the reference plane. So this line EF, which is blue in color, is parallel to both plane VP and HP both. Okay, so when we see that front view from here, and point E will be projected on vertical plane and point F will be also projected on vertical plane. Similarly, top view will be projected on horizontal plane, and we will write small e and small f. This is our top view with green line. Okay, so after rotating HP 90 degree clockwise, point E and point F will be projected just below E dash and F dash. So you can see this line EF is in its true form, either its front view or either its top view. Okay, so to obtain the projection of this line, draw an horizontal line, reference line XY, and mark point E dash and F dash. This distance is above HP distance, and this distance E dash and capital E will be given to you as in front of VP distance, which will be projected just below the reference line XY, this particular distance. Okay, so E dash and F dash we will mark here with the red color, and E and F are shown by green color. This is the case when the line is parallel to both the reference plane. So now move to next case, which is line contained by one or both the planes. Line contained by one or both the planes. So this is the case when the line is contained in the plane, either it's one plane or both the plane. First case is when the line is in horizontal plane. This is our horizontal plane. This is our horizontal plane. This is vertical plane. Okay, and the line is in the horizontal plane but making an angle with vertical plane. Okay, so this is our line capital AB, which is shown by blue in color. When we see from top, we can see the true shape of the line, which is the small a and small b right over here. Okay, so the top view will give you the true length of line, and its front view, when you are standing over here, point A will be projected on this, where the HP and VP are intersecting this particular line. We can see the front view with red color, and it is shown by small a dash and small b dash, right? So when we draw the projection, draw a reference line XY, and on this particular reference line XY we can mark a dash and b dash, but we don't know the length of a dash and b dash, so we will start with top view, because in top view we can see the true length of line. So take the reference line XY and mark this point capital A. If angle is given, then make an angle, this one angle with the vertical plane, and draw this line and mark point B, which is equal to capital small a and small b is equal to length of line. Okay, so the top view is drawn with the blue color and the front view is projected. Point A is just above the A, point A dash is just above the A, and point B dash is just above the B, because we take the projection in this particular direction. Okay, so this length is shorter than the true length of line. Okay, so we don't know the length of line, so we'll start with top view. In second case, this case is opposite. The line is making an angle with horizontal plane, but the line is contained in vertical plane. Line is shown by blue color with capital CD symbol. Okay, when we are standing over here, the front view is just there when the line, where the line exists, because line is already in vertical plane and front view is projected on vertical plane itself, and the top view is shorter and shown by small CD and in green color. Okay, so the true shape of line is visible in front view. We will start with front view, draw a reference line XY and mark point C dash, which is equal to the above HP distance, and this distance is also above HP distance. In case angle is not given, take the reference line XY and mark point C dash and mark point D dash also, and this distance will be, this distance C dash D dash will be equal to the length of line. So write C dash and D dash and project top view small with small cd, and this top view is shorter than the true length of line, right? This is the projection line, sorry, this is the projection line. Okay, so this is the case. Last one is line contained by one or both the planes. So both the plane case is this one. Line is both in HP and VP. We have studied in projection of point also, there is only one case where the point can lie in both HP and VP, which was on the origin. Similarly, where the HP and VP are meeting, this particular line is the line where the line is contained by both vertical plane and horizontal plane. So line is shown by capital EF, and the front view and the top view are projected where the line lies itself. So the front view will be drawn above the reference line XY and shown by E dash F dash, and here we can also write EF also. So when either you see from front view or top view, the point will lie here and the line will not be shorter. Okay, so draw a reference line XY and over here mark the EF and E dash F dash in this kind of a manner, and the length of E dash F dash, or you can say EF, is equal to the length of line. So this was the second case. Now move to third case, which is the line perpendicular to one of the planes. Okay, line perpendicular to one of the planes, either HP or VP. These are the two cases. Line is perpendicular to horizontal plane. This is our horizontal plane, and line is perpendicular to horizontal plane but parallel to vertical plane, and the line is shown by blue color with AB, and the front view will be projected on vertical plane and shown by A dash and B dash, and line will be equal to the length of actual length of line. So capital AB and A dash B dash will be exactly similar length, but when we see from the top view, the point A will be visible only, but the point B is hidden behind point A. So in the top view we will see only small a. If we want to write small b also, then mark a comma and write B also, but the B is hidden below capital A and only a point is visible, because see, this is our pencil. When we see from the top, we can say it's pointer only. So this is the point in the top view. Similarly, in this case, when the line is parallel to HP but perpendicular to VP, okay, line perpendicular to one of the reference plane we are studying, and in this case line is perpendicular to vertical plane. So line is shown by blue color and naming is CD capital, and when we see from the top view, line is seen in its actual length. So this is the true length of line. Line will not be shorter because it is not making an angle, and when we see from here, this is the front view, we will see only D point and C point is hidden behind it. So we will mark a point only and mark D dash comma C dash. C dash is optional because visible point is only D, so you can write D dash comma C dash, whatever you want to write. So draw a reference line XY. We are making the projection of this particular case, and this distance is above HP distance. Mark this distance above HP and mark point B dash and A dash also, and A dash B dash length is the length of line. So darken it with the H pencil, and this length is this length from reference line XY and up to point small a is the distance, this one A dash A, which is the in front of VP distance. After rotating HP 90 degree clockwise, this point A will move below the A dash B dash, and this is the distance, and we will keep it very light with the help of 2H pencil. We will darken only point A, or you can say B also. It's your choice. If you want to write small b, you can write it, otherwise ignore it. So to draw the projection of this particular line, draw the reference line XY, and the above HP distance is from here to here, and mark point D dash. If you want to write C dash also, then write C dash also. Okay, so this is the in front of VP distance, this particular. After rotating HP 90 degree clockwise, this will move to below the reference line, and C and small d is the length of the actual length of line. Line will not be shorter. This will be the our final case. And now move to in this video's last case, which is line inclined to one plane and parallel to other plane. This is the case. See, this is our vertical plane and this one is our horizontal plane. Okay, so line is making an angle. Line is making an angle with the horizontal plane, but it is parallel to vertical plane. Okay, so this is blue color is showing the given line, which is shown by capital AB. When we see from the front view, point A dash and B dash will give you the true length of line, and in front view the line is in its true form. Line will not be shorter. So write here A dash and B dash, which is equal to capital AB. When we see from the top view, point small a and point small b, and the green line shows the top view, which is shorter than the length of line. So if we want to extend this particular point, if we want to extend this line and extend its top view, here we can see the angle made by the line with the horizontal plane, and the line is parallel to vertical plane but making an angle with horizontal plane. So to draw the projection, draw in reference line xy, mark this point A dash and make an angle theta, and draw this particular line, and point here your compass needle and mark B dash and write here A dash and B dash. Okay, so just below it we can draw the its top view and draw small a and small b. Okay, so this is our final projection. And in move to second case, which is line is inclined to vertical plane but parallel to horizontal plane. So this is the given line, capital C D. Okay, so in which view we are seeing the true length of line? In the top view, right? Green line is showing its top view, which is equal to the length of line, and the front view is visible very short because we are standing here and point C will be projected here, and the front view is shown by red line, and this is D dash just below the capital D. So you can see clearly C dash D dash is smaller than the length of actual line, blue line. So when we extend this capital CD line here and extend this front view here, we can see the angle theta made by this particular line with the vertical plane. Okay, so to draw the projection, draw in reference line xy, and we will start with top view, right? Here we have started with front view because the length of line was visible in front view. In its true form, the line will be shorter in top view. Here in this case, the line will be in its true shape in top view. So start with top view, draw in reference line xy. This distance is c dash, small c dash c. This is the distance in front of VP. So mark point C over here, make an angle theta, and draw this line, and put your compass needle over here and cut here, and this will give you top view, and the front view is projected just above it. With the help of drafter, we will obtain the parallel lines, and this will give you your front view. Okay, so these are the 4 cases we have studied. In next video we will cover the rest of the 5 cases which were line was inclined to both the reference plane and how to calculate the traces of line. So if you like this video, then please like, comment, and share and subscribe my channel and to your friends also. Thank you very much.